Hey guys, so this is going to be a video about tryptophan. So I'll basically be talking about the few pathways like serotonin formation, melatonin formation, or niacin synthesis. So these are basically the three main pathways. The first one is niacin formation. Then we've got serotonin, and we've got melatonin. Now, what's interesting is niacin. So, you need to understand that whenever tryptophan is affected, like if it is not taken in, so what you're going to see is not any effect of tryptophan deficiency. Like, there's no such thing as a tryptophan deficiency. What you're going to see is niacin deficiency, serotonin deficiency, and melatonin deficiency. So, if niacin is pellagra preventing agent, right? So, pellagra. If it is preventing, so tryptophan deficiency will lead to pellagra. Serotonin is it is basically the hormone that is going to help you to stay happy. So it kind of elevates your mood, right? It is a mood elevator. It gives us the sense of happiness. And melatonin is about your diurnal rhythm. And now the biochemical component of melatonin diurnal rhythm is basically when light falls on melatonin, it gets dissociated, and we get the sense of wakefulness because we are awake in the light usually, right? So that is like the basic funda. But in case of physiology, we know that we talk about the suprachiasmatic nucleus and the pathway of diurnal rhythm being regulated around the hypothalamus. So that is a different thing altogether. So we have got niacin, serotonin, and melatonin synthesis. So basically we are going to start from tryptophan, right? Any pathway in this case will start from tryptophan, and you need to remember, like, the middle steps at least we'll have to remember, obviously. But in university or in any exam, if you're not able to remember the intermediates, just remember that at least you have to reach till 3-hydroxyantranilic acid. Now, why do I say that? Because after 3-hydroxyantranilic acid, you can just show like a bunch of arrows and just show that niacin is getting formed. Rather than, you have to mention the intermediates in a 10-mark short note or something like that. But just, pour in some that you can remember in between. Don't need to remember everything. So basically tryptophan first gets converted into N-formyl tryptophan. Sorry, N-formyl kynurenine. And the enzyme involved here is tryptophan pyrrolase. Right? So what happens is tryptophan pyrrolase converts tryptophan into kynurenine, and a formyl group is added. But now this formyl group is not actually necessary for the further steps, so we need to remove the formyl group essentially. So what we do is we take the enzyme formylase to remove the formyl group, and we get kynurenine. Now we know we have to reach 3-hydroxyantranilic acid, right? So we'll get something which is close to 3-hydroxyantranilic acid, which is 3-hydroxykynurenine. And now we know that just the hydroxyl group is attached. The only difference between these two is this hydroxyl group. So we did take the help of enzyme hydroxylase, which is kynurenine hydroxylase. Now this kynurenine will get converted into 3-hydroxyantranilic acid with the help of enzyme kynureninase. So we've gone from tryptophan to 3-hydroxyantranilic acid, and now from 3-hydroxyantranilic acid we need to reach niacin, right? So what we need to understand is that niacin is like formed from nicotine. Like we know, like when we talk about vitamins, the active form is supposed to be niacin. It's not like the compound itself is named niacin. Now B3 gives niacin, and B3 is mentioned as nicotinic acid. So we know that the nicotinic acid is going to be somewhere in the pathway. Like niacin is supposed to be the activated form, right? Activated state. So what we'll do is we'll get the 3-hydroxyanthranilic acid. It will get converted into quinolinic acid, which will get converted into niacin. But this is still not the active form. Niacin, as we know, NAD, NAD plus, NADP, ये सारे जो भी substrates थे, all these substrates were the active forms, right? Like the coenzymes, right? So basically these coenzymes are going to be taking part in a bunch of reactions. We know that at every step, be it be glycolysis or HMP shunt, everything kind of evolved around the concept of getting NADH plus or NADPH, which is obtained from HMP shunt, which is useful for the maintenance of basically the the RBC membrane integrity. So anyways, so like we have to convert this niacin to its active form, which is NAD plus and NADP plus, right? So what we'll do is basically we'll convert this into NMN first, which is mononucleotide of the, like we need to convert it into a dinucleotide. So first we'll convert it into a mononucleotide, and then we'll get ourselves the dinucleotide, and then we'll just phosphorylate it to get ourselves the NADP plus. Now the only thing you need to remember here is the enzymes, which is QPRT in this case, which is basically quinolinate phosphoribosyl transferase, right? So this is the enzyme where PRPP is actually used. Now PRPP, phosphoribosyl pyrophosphate. So basically this compound is also mentioned in the nucleotide synthesis pathway for purine metabolism. When we take into purine metabolism, so we see that the 5-ribose phosphate or ribose 5-phosphate is getting converted into PRPP, right? So PRPP then gets converted into phosphoribosylmine, and then we have got the further steps where GAR, FGAR, so like those substrates are formed. Then we've got ourselves let's just get a quick rewind of what we've learned till now. So we started from tryptophan, we went from niacin to what exactly does deficiency of niacin suggest. Then we got to know that we need to at least reach 3-hydroxyanthranilic acid in order to reach niacin. If you don't remember anything like the substrates that we are talking about in between, just show that this gets converted into niacin and that niacin is getting converted into NAD plus and NADP plus, right? And basically what you can do later on, if you are not able to elaborate this thing, just try to elaborate the functions of NAD plus and NADP plus, and then write an applied of the tryptophan deficient, like you can write a applied about Hartnupp's disease. Yeah, so Hartnupp's disease we can write about, because Hartnupp's is basically not perfect absorption of tryptophan. Then we'll move on from tryptophan to N-phenol kynurenine, then kynurenine, 3-hydroxykynurenine, 3-hydroxyanthranilic acid. Then we got ourselves through the intermediate NAD plus and NADP plus. Over here you can remember that NAD plus kinase is used, because kinase in any reaction means the addition of phosphate, right? Because made be phosphofructokinase, which was the key enzyme in glycolysis, it was just adding one phosphate group to fructose 6-phosphate, right? So we got fructose 1,6-phosphate, or pyruvate kinase, which was basically adding phosphate group to the phosphoenol pyruvate group. So any kinase is what adds a phosphate group to the given precursor. So now we've got ourselves the formation of niacin, and the functions of niacin is basically wherever you found the words NAD plus and NADP plus, that was the function of niacin. So it is like everywhere in every cycle, may it be the carb pathway, may it be the fat pathway, or may it be the protein pathway. Every pathway requires NAD plus and NADP plus, because these are the main reducing coenzymes, oxidoreducing coenzymes, type 1 or phase 1 coenzymes, which are basically responsible for the transfer of hydrogens. And proton transfer is something which is the core of any oxidoreductive reaction. So for that you need to have these coenzymes. Then we move on to the next pathway, which is essentially going to be the formation of serotonin, which gives way to the formation of melatonin. So if we talk about serotonin, so the pathway for serotonin is pretty straightforward. Tryptophan will first get converted into 5-hydroxytryptophan, and then 5-hydroxytryptophan will get converted into 5-hydroxytryptamine. And surprise, surprise, this is the serotonin. Yeah, it's that easy, guys. Why is this here? Okay, so it's very easy. Tryptophan into 5-hydroxytryptophan and that into 5-hydroxytryptamine. The only thing you now need to remember is the enzyme, which is pretty easy. We've got only a difference of hydroxylase, so hydroxylase, right? Tryptophan hydroxylase. And then here we've got an amine group added to the tryptophan group. So what basically is going to happen is tryptophan in itself is an amino acid which has an amine group already. So what it does is actually where the H is supposed to be there, the extra H in the 4 valencies of the amino acid, it is going to get dragged on to NH3 plus. So basically amine group is getting added. So for that we need a transaminase. No, sorry, transcarboxylase or transaminase. Transcarboxylase will be required, and then we'll get ourselves the tryptamine. And what this transcarboxylase does is actually it is going to remove the COH. Yeah, that's what I meant. राइट. सो बेसिकली CO2 अगर रिमूव हो रहा है तो ऐसे समझ लो कि जो भी हमारा अमीनो एसिड था उसके ऊपर जो भी R ग्रुप था, है ना, फिर एक COH था और एक NH3 था. सो इस केस में क्या हो रहा है कि और जो भी मतलब H था, है ना, तो इस केस में हो क्या रहा है कि हम ये जो कंपोनेंट है उसको निकाल दे रहे हैं. तो बच क्या रहा है, अमीन बच रहा है, इसलिए द प्रोडक्ट वी आर गेटिंग इज ट्रिप्टामीन, राइट. So we remove the CO2 over here, so that is why we'll get the product. Now 5-hydroxytryptamine is getting converted into 5-hydroxyindole acetic acid. Now this is very important because this is a diagnostic for more metab, right? So basically if there is more metabolism of tryptophan going on, you'll get the end product, right? You'll obviously get the end product. So that is where this comes into place. Excuse me. So then the tryptophan gets converted into 5-hydroxytryptophan, then tryptamine, and then we've got ourselves the 5-hydroxyindole acetic acid. Excuse me. I'm sorry, guys. So yeah, then for the melatonin pathway, the serotonin simply gets converted into melatonin with the intermediate of N-acetyl serotonin. And you don't even need to remember the enzymes. If serotonin is like an acetyl group is getting added to serotonin, so acetyl transfer is over there, And from N-acetyl serotonin to melatonin, we basically need SAM and SAHA, which is S-adenosyl methionine and S-adenosyl homocysteine. So there's going to be a methyl transfer in that case, so just a methyl transferase. So you don't need to mug up the enzymes per se, because if you do know which group is getting transferred, you just need to, or you know what is happening, like you can just make up the enzyme over there. And then we've got ourselves melatonin. Melatonin is useful for the diurnal rhythm regulation. So they can ask you that why is sleep impaired, or why is your rhythm impaired in case of heart nerves, or you know, why do we get pellagra like symptoms in case of heart nerves? So the answer is pretty straightforward, because tryptophan is not getting absorbed. So the three major components that it is forming, that is niacin for serotonin and melatonin, are not getting formed, and because of that you need to have some sort of an explanation or a previous idea about what exactly tryptophan, niacin or serotonin or melatonin does. So niacin is responsible for various reactions, all the basically. So every metabolism will be hindered, and you will get pellagra. Pellagra is basically the four D's determine pellagra, right? We've got dementia, we've got dermatitis, then we've also, like, if the situation is way worse, then it can also lead to death. So like the definition and the causes of the symptoms due to pellagra, due to niacin deficiency, can be explained over there. Then we can go for serotonin. You have to talk about how serotonin is responsible for the elevation of mood, and maybe if tryptophan deficiency is taking place, then it can lead to basically irritability of that person, and it can lead to bipolarity sometimes, because that is like, bipolarity is basically a swinging between maniac phases and the depressive phases, which is like alternating emotions always. And then we've got melatonin. So melatonin is responsible for the diurnal rhythm variation. So diurnal rhythms are not just the sleep cycle per se. Melatonin will be concentrating on the sleep cycle, but diurnal rhythms include any sort of cycle that is existing in the human day-to-day life, right? So even let's say menstrual cycle is a rhythm, it's a diurnal rhythm, but it's not related to melatonin per se, right? So yeah, it is responsible for diurnal rhythm regulation. Then we'll just go and explain all this. You write the enzymes, you try to mug up the enzymes, they'll ask, and just write down every step. Like you write down the pathway first, then write one page for the step, one page for the pathway. You've got 2 pages already, so you'll score enough marks. So yeah, there's that. You remember this thing at least, that कि 3 tryptophan से 3 हाइड्रोक्सीएंथ्रेलिन तक तो जाना है कम से कम, मतलब कैसे भी जाओ. अब ये इतना याद रहा तो ठीक है, नहीं याद रहा तो भी इट्स ओके, चिल. नियासिन से फिर NADP प्लस तक जाना, फिर ट्रिप्टोफान से डायरेक्टली जो हम ट्रिप्टामिन तक पहुँचे वो याद रखना, और इसके बाद का ये जो स्टेप है ये भी याद रखो, क्योंकि ये एक डायग्नोस्टिक मेजर है, क्योंकि अगर ज़्यादा मेटअप हो रहा है तो फॉर्मेशन ज़्यादा होगा. सो इट इज़ गुड इफ़ यू रिमेंबर दिस. देन मेलाटोनिन का आप इतना ही रिमेंबर करना है कि सेरोटोनिन से मेलाटोनिन बनता है, एनासेटाइल सेरोटोनिन विल बी द इंटरमीडिएट. और अगर आपको एंजाइम याद ही रखना है तो सेरोटोनिन से एनासेटाइल कैसे बनेगा, तो एसिटाइल ट्रांसफरेज से, और एनासेटाइल से मेलाटोनिन कैसे बनेगा. सो इट विल बी, बिकॉज अगर वहाँ पे सैम और सा यूज हो रहा है तो ऑब्वियसली देयर विल बी अ ट्रांसमिथाइलेज. सो या, वी आर डन विथ ट्रिप्टोफैन मैकेनिज्म. दिस वाज माय फर्स्ट बायोकेमिस्ट्री वीडियो एंड इट इज़ वेरी लॉन्ग, आई नो. 2x पे देख लोगे तो आई गेस यू कैन skip my blah blah blah. And I hope you like the video. If you do, subscribe, because I don't want subscribers essentially, but I just like making videos. In my study time, it's like it's like a getaway from everything. So thank you for watching, and I hope you like the video and it's helpful. ये आपका 5 मार्क का शॉर्ट नोट तो एटलीस्ट रेडी हो गया है. थैंक यू एंड हैव अ गुड डे.